Okay, this is the last section in the periodic table unit. It's 4.5. And we're going to actually start these notes right after the worksheet for 4.4. I just wanted to relate back the reactivity of the elements based on their where they are in the periodic table. So the most reactive metal, as you can imagine, is going to be francium. We could also say it has the most metallic behavior. So why do we say that? It's because it has the lowest ionization energy. And that means that it most easily loses an electron. And that's how metals react. They become a cation and react with an anion. So the most reactive nonmetal is fluorine. Why is fluorine the most reactive nonmetal? Well, it has the highest or most negative electron affinity. So it most easily gains an electron to become an anion. And just like we said with the metal, the way a nonmetal becomes reactive is it forms an anion. Okay. So let's talk about metals, nonmetals, and metalloids. So if you look at the periodic table, these in silver are all metals. So the vast majority of elements are metals. So before we fill out the notes, I'm just going to take you through a couple of slides, and then I'll come back and show you where to put your notes in. But again, the metals are located on the left side of the periodic table. They are most of the elements. The only element that's on the left side that is not a metal is hydrogen. And then there are, of course, far fewer nonmetals, and they are on the far right-hand side of the periodic table. And then along this stair step, you have these green elements, which are the metalloids, which have properties between those of metals and nonmetals. So let's just take a quick look at some metals. So here is nickel, rubidium, gold, and copper. So you can see they are all kind of shiny. These two are silver. These are not silver, but most metals are going to be silver. Non-metals vary quite a bit. This is sulfur. Nitrogen is a gas at room temperature. Selenium is kind of like a rock. And bromine is a reddish brown gas. Okay. Metalloids are between the metals and the non-metals, and they share properties of both. They're pretty shiny. They are mostly silver. Okay, so let's go ahead and fill out this table. So first, let's talk about the location on the periodic table. So the metals are on the left-hand side. The non-metals are on the right. And the metalloids are along that stair step, those few elements. Properties, these are the properties we're going to talk about. So the state at room temperature for a metal is almost all of them are solid. The one exception to that is mercury, which is Hg, and it is a liquid at room temperature. But most of these, there are going to be exceptions to everything I say, but for the most part, metals are solid. Non-metals vary. They could be solid, they could be liquid, or they could be gas when they're at room temperature. And metalloids, just like metals, are mostly solids. From a color standpoint, most metals are silver, but like we saw, there are a couple that are not silver. Gold is gold, and copper is sort of that reddish brown. Non-metals vary quite a bit. And let's look at some examples. So sulfur is this bright yellow. Iodine is purple, exists as a solid. Chlorine is a gas, it's a green gas. Phosphorus is a red solid, and we already said bromine was a reddish brown gas. Metalloids tend all to be silver. Okay, metals tend to be shiny, non-metals tend to be dull, and metalloids, as we saw in the pictures, tend to be shiny also. Now, metals tend to be very malleable, which means I can hammer them and form sheets. They will not break apart, but they will take a shape by hammering them. Ductile means I can draw them into a thin wire. And so metals are both malleable and ductile. Non-metals, of course, we're talking about the ones that are solid, tend to be brittle. And most metalloids are also malleable and ductile. When we talk about how conductive elements are, we can talk about both electrical conductivity and heat conductivity. So metals are very electrically conductive. The nonmetals are not conductive, and metalloids are semiconductors, which makes them very valuable in the electronics industry because they can be used to tailor what happens. You can add pieces of or some areas of these semiconductors, which will tailor these chips so that they perform in a specific way. In terms of heat conductivity, metals are conductive of heat. So if you put a spoon in a pan of boiling water and the spoon is metal, you will feel that on the handle. The heat will conduct up the metal. Non-metals, those that are solid, of course, tend to be insulators. So they do not conduct heat. And metalloids vary, but for the most part, they do conduct some heat. Okay. So let's take a look at some specific groups of the periodic table. Alkali metals have one valence electron. They are the most reactive metals. They are soft enough that you could actually cut them with a knife. They exist only in compounds, and that's because they are so reactive. You won't find, for instance, sodium in a mine. You'll find sodium chloride in a mine, and that's because it's so reactive. It is unstable as an element, and it's more stable in a compound. Alkaline earth metals are also reactive, but not as reactive as alkaline metals. But they are reactive enough that you will find them only existing in compounds, again, because they're more stable that way. The transition metals, all these light blues here, they tend to be hard and shiny and somewhat reactive, less reactive than group 1 and 2. And all of the transition metals also have 2 valence electrons, okay? Alkaline earth metals group 2 also have 2. Halogens on the other side, this is fluorine, chlorine, bromine, they have 7 valence electrons, and their properties are, oops, let me just stop this here. I'm going to stop sharing for a second and then share again. So the halogens are the most reactive nonmetals, and they can be solid, liquid, or gas. Bromine is a solid at room temperature. Fluorine and chlorine are gases. Iodine is a solid. Okay. Actually, bromine is a liquid at room temperature. Iodine is a solid. Noble gases are specifically known for being unreactive because they are already stable, so they tend not to react. On the bottom of the periodic table, the first row of the F block, are lanthanides. They tend to be pretty reactive. They're silver, they're soft, so a lot like the other metals. Actinides, what's unique about them is they all tend to be radioactive. And the most recent discoveries of elements are the actinides. And one way we talk about the age or how long an element will last is we talk about its half-life, or how long it takes for half of the mass of it to decay is half-life. And some of these newer elements have half-lives that are less than seconds long. So they are very fleeting. They are very specific isotopes. They are made, characterized very, very briefly, and then they're gone. So some would argue that they shouldn't be considered elements, but they do fit the classification. Hydrogen is kind of in a class by itself. It's a gas, it's combustible, it's not toxic. But many of you probably recognize this famous accident that's attributed to hydrogen. And this is the Hindenburg. It was filled with hydrogen gas because hydrogen is very light and not very dense. So it would cause the Hindenburg to rise quite readily. But it is also very combustible. And when it hit a wire, it blew up and killed a lot of people. Okay, so how is the periodic table organized today? The periodic table is organized by atomic number. The reason it was not organized by atomic number when Mendeleev put it together is because atomic number had not yet been, or the proton had not yet been discovered. So the elements left to right and top to bottom are organized by atomic number. And then of course the groups are organized by similar properties. With a few exceptions, the atomic mass trends follow the atomic number trends, but there are some exceptions. For instance, if you look at the transition metals, cobalt and nickel, their masses are reversed. Okay. So that's going to do it for us.